Picture this. It's 2 a.m. I'm completely in the dark.
Oh, no.
Right. I'm blindly fumbling around my kitchen trying to find a snack without waking everyone up.
Classic.
It's just bumping into cabinets, relying entirely on touch, just hoping to snap up a handful of pretzels. Well, it turns out 66 million years ago, a massive sea creature was basically doing the exact same thing to survive.
It's a great analogy, actually.
Welcome to Intellectually Curious. You sent us a stack of really fascinating research on Moroccan fossils today.
I did. It's a brilliant set of sources.
And our mission for this deep dive is to unpack how one recently discovered marine reptile completely rewrites what we know about the late Cretaceous oceans.
It really shifts the entire perspective on marine ecosystems right before the asteroid impact.
It does. But before we jump in, today's exploration is sponsored by Embersilk.
Right.
Do you need help with AI training or automation or integration or even software development? Uncovering where AI agents could make the most impact for your business or personal life? Check out embersilk.com for your AI needs.
Definitely check them out.
Okay, let's get into these notes you shared. We're looking at a mosasaur, right?
Yes, a massive marine lizard called Pluridens serpentis.
And it was huge, like 8 meters long.
About 26 feet, yeah. And the name itself paints quite a wild picture.
It really does. So Pluridens simply means many teeth.
And serpentis refers to its long, slender, snake-like jaws.
Ah, okay.
What stands out in the research is how those jaws were actually equipped. They were packed with dozens of small, hooked, recurved teeth.
Much like a modern snake's.
Exactly. Those are perfectly adapted for seizing and holding on to slippery, wriggling prey, so it simply cannot escape.
Which brings us to a really fascinating contradiction in the data here.
The dietary paradox.
Yeah, because you have this massive 26-foot creature, but it wasn't hunting huge whales or other large reptiles.
No, not at all.
It was highly specialized to just snap up tiny prey like fish and squid.
Precisely. And connecting back to your late-night kitchen run.
Oh, right, the vision aspect.
The skull fossils show it had unusually small eyes compared to other mosasaurs.
So it's hunting in the dark.
Right. Because of that reduced eye size, we can infer it was hunting in murky or deep water. It likely relied on mechanoreceptors or non-visual senses to track the subtle movements of its prey.
Just sensing the water moving around it, that's incredible.
It is.
Now, the sources note these fossils were found in the phosphate mines of Morocco. To give a quick geographical context for why we are finding ocean predators in a modern desert.
Right, 66 million years ago, that region was a shallow, warm sea.
Before millions of years of shifting tectonic plates pushed that ancient seabed up.
Exactly, exposing it as the arid terrain we see today. That is a crucial piece of context to keep in mind.
Because when it was a sea, it wasn't empty.
Not at all. It was a thriving, finely balanced ecosystem. Pluridens shared these exact waters with at least 12 other known mosasaur species.
12?
Yeah. For instance, there was Carinodontons, which was a much smaller mosasaur, adapted with blunt teeth, specifically to crush hard-shelled prey.
So if Pluridens was hunting small fish and Carinodontons was crushing shells, who was at the top of the food chain in these waters?
That would be Thalassotitan atrox.
What a name.
It was a giant apex predator with massive, heavy teeth, designed to actually hunt and eat other marine reptiles. The sheer variety of dietary specializations coexisting there is staggering.
Looking at all these specific niches, there's a brilliant insight here from Dr. Nicholas Longrich.
Oh, the diversity aspect.
Yeah, he points out that this rich diversity directly challenges the old scientific narrative that mosasaurs were in a slow decline before the asteroid hit.
Exactly. The fossil record from Morocco shows they were actually at the height of their evolutionary success.
Peaking, basically.
Radiating into highly specialized roles and dominating their environments right up until the mass extinction event.
So rather than a dying lineage, we're looking at a huge testament to the incredible adaptability and resilience of life on Earth.
It shows that life consistently finds a way to flourish, to innovate, and to build incredibly complex, stable communities when given the chance.
Which leaves you with such a fascinating question to mull over.
It really does.
If reduced vision forced Pluridens to develop an entirely new sensory system to hunt in the dark 66 million years ago,
What undiscovered hidden senses might the creatures lurking in our modern deep oceans be using right now.
Exactly. It makes you wonder what magnificent secrets of the universe are sitting just under our feet right now, waiting for human ingenuity to uncover them.
We're constantly learning more.
We are living in an era of unprecedented scientific discovery, and our boundless human curiosity is only going to keep solving these brilliant puzzles.
Absolutely.
We have such a bright, progress-filled future of exploration ahead of us. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.